Hello everyone, my name is Heng and welcome to my lectures today. The lectures today will introduce to you three hardest materials that ever created. It can be by nature or by humans. And we will also cover how these materials are formed and the applications in the today's sessions. So now let's start with the introductions. Today the three hardest materials that we are going to discuss are light, aggravated diamond nanorods, and diamonds. These materials are identified as subhard materials, which mean the hardness value are exceeding 40 gigapascal when measured by using the Vickers hardness test. Superhard materials have some characteristics such as high shear modulus and high bulk modulus, and they also does not deform plastically. So ideally, superhard materials should have a defect-free and an isotropic lattice. The first material that we are going to discuss today is Lonsdaleite. This material is named honor Kathleen Lonsdale, an Irish Pacific prison reformer and a crystallographer who proved that the benzoring is flat. Lonsdaleite is a harder form of diamond and was first identified in 1967 in the United States from the Canyon Diablo meteorites in Arizona. A study published in 2009 showed calculated data that indicated Lonsdaleite is the hardest material that ever known to human, with a Vickers hardness value of 152 gigapascal compared to only 97 for diamond, which means Lonsdaleite is 58% stronger than diamonds. So how does they create it? In nature, Lonsdaleite is found in meteorite debris. So when metal containing graphite strike the earth, the immense heat and strength of the impact transform the graphite into diamond pyrethane graphite hexagonal crystal lattice. So basically, the impact transform the graphite into a different form of diamond, but has a higher hardness due to the difference in the crystal structures. The figures on the top right is the crystal structure of Lonsdaleite, and on the bottom is the pictures of the Canyon Diablo meteorites where Lonsdaleite first discovered. So you can see how hard was the impact to create these materials. It can also be formed in laboratory synthesis by compressing and heating graphite, as well as chemical vapor depositions and polymer thermal decompositions. Lonsdaleite have various applications. It can be used in space science for making ultra-hard microscopic high durability machine components also can help to simulate the asteroidal impact on the planet's surface. Losala can be also super helpful for other heavy industries. For instance, in the mining and petroleum industry, Losala drill can help to drill faster and more accurately than the current diamond drill. It can also be used as an abrasive materials for cutting and grinding process in some industries, such as the manufacturing or construction industry. The second materials that we are going to discuss today is the aggravated diamond nanorods. So this is the densest and least compressible form of diamonds and first created by a group of Japanese researchers 20 years ago in 2003. It has a stronger hardness value than diamond with 105 gigapascal on a Knoop scale compared to only 104 for diamonds. So the reason why the article used the Knoop scale instead of Vickers scale is because they state that it is more precise than the Vickers method because the Knoop measurement diagonal is longer for any given indentation depth. I will not go in depth here, but we can know that the aggravated diamond nanorod could possibly exceed 10 on the Mohs scale of minor hardness. So the Mohs scale minor hardness have a higher score of 10 and it is belong to diamond. So since aggravated diamond nanorods is even harder than diamond, so it probably can exceed this 10. So how does they create it? The aggravated diamond nanorods are produced by compressing fluoride powder, which is a solid form of allotropic carbon fluoride, by two main methods. The first way is by use a diamond anvil cell and apply pressure about 37 gigapascal before heating the cell, sorry. And the second way is a compressed fluoride powder to lower pressures, then heat it to a temperature from 300 to 2500 kelvins. The aggravated diamond nanorods can be used for various purposes. It can be used in designing new type of structural ceramics, reinforcement in nanocomposites, hardcoring for industrial equipment such as the drill, or can also be used as an abrasive material for the grinding and polishing process in many industries. Last but not least, the final materials that we are going to cover today is diamond. Diamond is made of pure carbon in a crystalline form, and diamond is also the hardest natural materials that ever known on Earth with a Vickers hardness value of 97 gigapascal. It rated the highest score on the Mohs hardness scale, 10. And diamond is also one of the most expensive materials in the world due to its rareness. So, how does it create it? The diamond in nature can be created at the depth between 150 and 250 kilometers. This explains for how rare it is and how hard it is to find. So it is created in the earth mantle and also can only be carried to the surface by volcanic eruptions. Some diamonds are billions age old, and it means that these diamonds are formed at the very beginning period of the world, which means very long time ago. And in laboratories, people can also synthesize diamonds. So today there are two main methods to synthesize diamond in the lab's environments. Majority synthesized by using a so-called high pressure, high temperature process, while other are created by using the chemical vapor decomposition method. Due to the high value of diamond, it can be used as jewelry or investment property, and it can also be used in various industry, such as mining industry, semiconductor industry, and medical industry. Diamond also serve as an important materials for cutting and grinding tools, as well as a material of precision optics and radiation detection device. So this is a list of the reference that I used to prepare for this presentation, both articles and figures. Thank you very much for listening to me and hope you have a great day.